Assalamu alaikum warahmatullah. Bismillah ar-Rahman ar-Rahim. In this video, we are going to discuss about the FortiGate packet flow. And the FortiGate packet flow we are discussing without the security policy. And along with that, we are discussing the slow path packet flow. So whenever any traffic will hit at any interface, that interface known as ingress interface. On the TCP IP stack, following information will be take out or extract from the first packet. That information will be source IP, destination IP, source port, destination port, protocol, can be the TCP, can be the ICMP or UDP, or other protocol, sequence number in case of the TCP, acknowledgement, SYN, push, or you can say flag of the STP. And also it can be the information of the VLAN of the layer 2, or you can say simply it can take out the layer 2, layer 3 and layer 4 information. And all these information will be stored on the ingress interface. After these information that will be stored on the interface, the first packet will pass through the DOS policy. DOS means denial of service, or it can be the DDoS. It's a kind of DOS, distributed denial of service. And this DOS policy is applied to protect the CPU utilization from the kind of flood attack. That can be the SYN flood attack, or it can be the ICMP flood attack. In this policy, we set the threshold. If the data stream or packet are coming under the threshold, that will pass for the next process, IP integrity check. If incoming packet streams or data stream is beyond the threshold, then this policy will drop the packet. Only that packet will move to the IP integrity that is under the threshold. IP integrity will check whether the header of the packet is correct or not. And after the integrity check, that packet will move to the IPsec VPN decryption if the received packet is VPN. In our diagram, we have not configured the IPsec. It means this step will be skipped in our testing. It means after the integrity check, that new packet will go to the session table to find out is there is any session. But as we have discussed, it's a new session. It means the information of packet number 1 that is coming, packet number 1, it will not be exist into the session table. For the new data stream or new packet or the first packet, new session ID will be allocated, and that will remain the same till the traffic will not reach to the egress interface. And for the new packet, we will check the DNet. Is DNet is configured for the destination IP? Because if we will send the traffic, let's say from this IP address, that is the user on the internet, that is our source IP address. And if I want to send the request on this IP address, let's say 122.160.50.99, that is my destination IP address. And we have configured in this lab DNet for this IP address. And DNet IP address we have configured in the firewall policy, and DNet IP of this IP is 10.1.1.1, that is mentioned in the firewall policy. It means whenever the traffic will hit from this source IP address to this IP address 122.160.50.99, if net table will look up first, it means this IP address will be translated into this IP address in the DNet or net table. After looking the net table or DNet table, next process will be the route lookup. Route lookup for what? Route lookup for this IP address, how to reach for this IP address. Because the firewall can have the multiple interfaces, because we have shown here only one interface LAN, multiple interfaces can be there. Let's say DMZ interface will be there, let's say port number 4. Then what will happen when the traffic will hit on this IP address? It will reach to the port number 3. It will exit on this interface or this interface. That will look up into this routing table. In this routing table, we'll find out if we want to reach at this IP address, then exit interface will be the port number 2. And to reach on this router, we can go via this one. And in the output, it will display the gateway. That is the gateway to reach on this IP address. And after that, device will look up, Fortinet will look up for the policy. What policy says this traffic will be permitted or deny in the policy. Why we are looking the policy after the route? The reason behind is that maybe possible in the industry scenario, policies can be thousands, but the route we have written in the firewall can be only 10 or 20 or 30. That is less than the policies. That's why it's better solution to find out the route first and check the policies after that. And after the policy, if the policy is permitted with respect to this packet, then we will check is there is any policy for the SNet or not. We have already configured this Fortinet for the SNet. When this traffic with this IP address will hit on this IP address, that source IP address will be translated into this IP address, because we have configured the SNet on this port. It means this IP address will translate into this IP address when the traffic will exit from this port. It means this device will receive in the debug IP ICMP. If we want to test it, if we will send the echo request from here, we can see on this device, the source is coming this one, not this one, because this IP address is translated into this IP address. So according to the packet flow of the Fortinet, it will check DNet, then route, then policy, then SNet. Because we have not configured the security policy, it means it will bypass all these things, and this information will be stored into the session table on the same session ID that was allocated for the first packet, and that session ID will be stored here. When the subsequent packet will move from this device on this IP address, then when the packet flow will come here, it will go to the session table. It will look up the existing session ID. If existing session ID is there, then no need to look up further into the process to waste the time of the CPU of the Fortinet. Now, to verify this all the process, we can go to this lab diagram. And before go to the lab diagram, we can check the policies. We have created the two policies here. LAN to WAN policy, edit. If we want to send the traffic from LAN port to, it means from this port to port number 3, that is the WAN port, any source, any destination, any service. And we have on the net, so that whenever the traffic will go from this IP address to the outside, this IP address will be translated on the exit interface, because this one will apply on the use outgoing interface address. It's like the PET. This IP address will translate it into the 122.160.50.99. And when this return traffic will come back, or if the request is coming directly from the remote user to this public IP address, this WAN policy will be merged. In this policy, incoming traffic or ingress traffic is coming on the port number 3, and outgoing is LAN port number 2, source any. In the destination, we have made the policy, or you can say it's a net table. In this policy, we have mentioned here at any interface, it means port number 3 is coming under this one. And whatever is the IP address is coming, source is any, but in the case of the destination, the request will hit on this IP address. And this IP address will translate it or DNet into the 10.1.1.1. It means when this IP address will hit on this IP address, then this IP address, source IP address will be translated. The source IP address will translate into this IP address, and this destination IP address will translate it into this IP address. And before checking the debug flow of the Fortinet, we want to verify is they have the reachability or not. Go to the command line and we can verify here. Let's say if I am sending the request from the R1 and here debug IP ICMP, I am sending the request from this machine, let's say ping, and ping 122.160 and 50.89. I'm getting the reply. Now we can find out here. My source was the 10.1.1.1, but on this device, I am sending the echo reply to the source IP address. And that was my source IP address, 10.1.1. And this IP address is translating into the 122.160.50.99, because that is the destination IP address here, and that is the source IP address. When this device will reply, source will be this one, and destination must be this IP address, but this IP address has been translated into this 122.160.50.99. That's why remote user is sending the reply on 122.160.50.99. Now, similarly, I can verify here on the R1, I am sending the request from this outside IP address 122.160.50.99. If I am sending the request on this IP address, that is the source IP address, that is the destination IP address, My source IP address will be translated into the 10.1.1.254 because we have put the SNet on, we have applied the SNet, or we have enabled the SNet on the port number 2. We can see here on the R1, the request is not coming from this IP address 122.160.50.89, but really the request is coming from this IP address, but this IP address is translated into this IP address. That's why this IP address we are getting here, and my R1 router is sending the echo reply on this IP address. Now we want to check the packet flow that we have discussed about the Fortinet. For that Fortinet packet flow, we will go to the network and diagnostics and debug flow and increase the packet length so that we can capture all the packets. And protocol is TCP. Now I'm sending the request from the outside so that I can show you the DNet and SNet both. On all. Now I will send the request for the telnet, and for that I want to first enable the telnet on this device, line VTY04, password and CP, and transport input telnet, so that we can check the TCP flag also with the sequence number and acknowledgement and other flags. Now send the request from the outside, that is the remote user. I am sending the request telnet, but before sending the request, I will turn on the debug flow 50.99. Now go to the FortiGate and debug flow. I will start the debug flow here, and after that I will hit this command, enter, then enter. Now I will stop this one, and matching information I will save in CSV file, then we will discuss. Otherwise, may be possible that output can be removed from here after the ideal session. And we can save this one, show packet flow, and that is our output. Most of the information is not usable for us. I will first remove this one, and then I will discuss with you. Our information will start from the sequence number 36. That is our SYN packet, and I will color it so that you can recognize easily. Just wait for a moment, and $36, that is the output. Just wait. SNet, and that is the SYN flag and the acknowledgement. It means that is our output. Just wait. from this point to this point. Acknowledgement, that is flag, SYN flag, and is I am just pausing the video to take out the real output. So that is the output that we have captured. I have taken out all the output from there. Now we can find out according to the our diagram. That was the I have taken out the output from this entire debug flow we have captured, and that is our diagram. And according to this diagram, that is the output we have captured here. I have sent the request from this IP address. That was the source IP, and that was the destination IP address. When the request will hit on this IP address, destination IP address, that IP address will be translated into this IP address in the DNet. And this source IP address will also be translated when this IP address will move from port number 3 to port number 2. This IP address will translate it into 10.11.254. And in the reverse, source IP address will be this one, and destination IP address will not be this one. Destination IP address will be 10.11.254. That will be the source in the reply, and that will be the destination, and that destination IP address will DNet into this IP address, and that source IP will translate it into this IP address. It means source IP address in the reply. Now we can see here in the output, and we can easily understand each and everything. That was the first packet. The received packet, that was the protocol number 122.160.50.89. I can make the roughly diagram here to understand the concept. That is the firewall, and the firewall, the port number is, that is the port number 3, and that is the port number 2. And this interface is connected to the internet, and on the internet there is one remote user, and IP address of this user is 122.160 and 50.89, and IP address of this port is 122.160 50.99 on port number 3. That is the LAN port, and that is connected to through the switch to the R1, and that IP address is 10.1.1.1, and port 2 IP address is 10.1.1.254. I have sent the request of the telnet from this IP address. From this IP address, that was the source port. On this IP address, that is the SYN request I have sent here. Flag as means SYN request, and destination IP address was the 99 and port was the 23. That is the on port number 23. And the port number of this one was 31. That will be the dynamic source port. and that was the SYN packet, and that was the sequence number 306 in the last. Because that was the first packet, it means allocate a session or new session ID. You can note down here 0000 four times, then 4, then 2, then E, then 7. This session ID will remain the same. And that first packet was hit on the input interface, that was the port number 3. And when this packet will hit on this one, first what we will look up, we will look up the DNet. And that is the, we are looking for this IP address is destination IP address. For this destination IP address, that is the destination IP address, that is the source IP address, and that is the destination IP address. Is there is any NAT policy for this destination IP address? We have find out that is the destination IP address. And this destination IP address basically is formed in the into the NAT policy in the virtual IP address and port number 23, and out device port number is 3, and that is the NAT entry we have find in the NAT table. If destination IP address is this one, this is the port, then that IP address will translate it into this IP address, and this port number will remain the same. Now, after the NAT table lookup, the second lookup will be the route lookup for this destination IP address. Now, what is the output interface? Because firewall can have the multiple interface. Let's say port number 5 can be here. If the traffic is coming here, it will go to this port or go to this port. That will look up by the route table. In the routing table, this IP address can be accessed through port number 2. It means the traffic we have sent on the port number 3, it can exit from this port, and from this port it can reach to the this port that is mentioned here via GW gateway, this one. And after the second process, third process will be the policy. What policy says, it is allowed or it is rejected. And we can see here in the output, policy says the policy is accepted here. Policy is accepted here. Port number input is 3, outgoing port is 2, and policy is accepted here. Is there is SNet is there? We can find out the entry for the SNet is exist not. We have find out the entry for the SNet, that will be the SNet. And SNet for which IP address? The IP address that is coming in the source IP, that is the source IP. For this IP address, is there is any matching in the SNet table? We can find out here. For this IP address, this is the IP address that we have find into the NAT table, and we can see clearly this IP address 122.160.50.89 that have the port number 31530 is netted into this IP address on the same port. That was the SYN packet that receive here, and it's going to the port number 2 according to the policies, or that is the ingress interface, that is the outgoing egress interface, and we are checking the flow without any security policy. Now the second packet will be the, that will be in the reply. It means it will send from here on the port number 2, that will be the SYN-ACK. And we can find out the SYN-ACK. That's a lot of process is there in the first packet, but in the second packet we will find out only few processes there. Just wait, I will remove the marking from here, and I will go to the SYN-ACK packet, and that is my SYN-ACK packet. See, in the SYN packet, the sequence number was in the last 307. It means when the acknowledgement will come back, it will be 307. We can recognize here that is 307. That is the receive packet from the R1 towards the firewall so that it can go to the this IP address. Protocol number is 6 and the source is this one. Source is this one. Port number is negotiated port number 3. And we are going not on this. We are sending the request not on this IP address. We are sending the request on this IP address because that IP address was the source netted. That IP address was converted into this IP address. It means in the sequence, in the SYN packet, R1 receive the request from this IP address. That's why it will send the reply to this IP address. That's why it's sending the reply to this IP address on the port number 31530. And this dot here is representing the ECK. And S stands for the SYN. It means that package is going from the R1 to 10.1.1.2.5.4 is a SYN packet. And the session ID is the same. You can match from here. The registration ID is the same. And that is the reply direction. That is the reply direction. We are going in the reverse direction. And we are sending the request. That is the source IP address. That is the source IP address. And that is the destination IP address. And we can see here one more thing. This destination IP address is translating into the this IP address 122.160.50.89, 122.160.50.89. And because this process is taking first time, this reply is coming from the R1 to this IP address to this section is the first time. That's why after the DNet, because that is the DNet, whenever the first packet is coming at any interface, because in actual way, it's an acknowledgement of this SYN packet, but on this interface, this packet is coming first time. That's why the first process will be the DNet and the second process will be the route. And this route, we have the find out the route to reach at this IP address through this port via this IP address, 89 IP address. When we will move from this port, and if we want to go to the 122.160.50.89, it means we will go through the this IP address, this IP address. And that is the DNet and this one. And we can see here, we are not checking the policy because that is already in the session table. And this IP address from the session table, we are taking this source IP address for this SNet. For this SNet, we are not taking any routing lookup. We are checking for this net, for this IP address is translating into the 122.160.50.99. And that is, we are taking information from the session table. It's going directly there. And in the SYN packet, we are looking how to reach at this IP address on the netted IP address. But in the reply, this IP address is sending the request to this IP address. And this IP address is DNetting on this IP address. And we are looking for this destination IP address route. And that is find into the routing table and on the port number 3. And it will move from here to here. And that is the reverse direction of the SYNEC. That was the SYNEC was the first packet, SYN was the first packet, and SYNEC was the second packet. And when the reply will come back, we will find out in the SYN packet that was the lot of processes there. But in the third packet, that we will receive from here, and it will will flow like this. That is the packet number 3. That will be the acknowledgement. We'll find out in the bottom all the process has been minimized because we have all the entries in our tables, and we can see here. Now this packet is coming from where? This packet is coming from where? This packet is coming from the original direction, from the direction SYN packet was came on this interface. That is the third packet from the remote user. Source IP protocol is this one, source IP address is this one, and destination IP address is this one. Yani destination IP address is 122.160.50.99, but we are not going for the DNet lookup. This entry is already taken from the session table, and we are not checking the route for this IP address. Route is already there. It means we are taking this information, and this information, SNet information, we are not looking the SNet table for this IP address in the acknowledgement, because this process already has been completed in the SYN packet. That is the real direction or original direction in the third packet. And the first packet, if you can see again here, that was the lot of processes there. We are doing the lookup for this IP address 10.1.1.1, and we are finding the route here. We are checking the policy here, and we are checking the SNet table for this IP address 122.160.50.89, and we are checking the, after checking the SNet table, and after that we are allocating this IP address will be translated into this IP address. But in the subsequent packet or in the third packet, we can see here we are not checking any DNet table, any route table for the SNet or the DNet. We are taking the information from the session table. That was the flow logic that we have captured here. I think it will be beneficial for you. Thank you for watching this video.